Hello, I welcome you to this video where we want to look at the concepts of a speed time graph. So this question has been picked from the ECZ Mathematics Paper 1 for 2025. So going to the question, it says the diagram shows the speed time graph of a moving object. So what we can see here is the diagram representing a speed time graph of a moving object. Now part A says find the acceleration of the object in the first 8 seconds. Okay, so we need to understand that acceleration is the change in speed with respect to time, okay? And the data that we can collect in this part of the question is that velocity for the first 8 seconds, the final velocity is going to be equal to 20, and then the initial velocity, u, is going to be equal to 0. Then the time is going to be 8 seconds. So using this formula, we can calculate the acceleration, and we are going to say acceleration is equal to, so we substitute into the formula, we have 20 minus 0 over 8. So acceleration is equal to 20 over 8, which is going to simplify to, when we divide 8 into 20, we are going to have 2.5 meters per second squared. So this is going to be the acceleration in the first 8 seconds. So that is for the first part of the question. We can move our attention to part B, which says, given that the object covered a total distance of 115 meters in the first 10 seconds, find the value of V. So this object covered a distance of 115 meters in the first 10 seconds. 10 seconds is up to this point. And we've been told that the distance up to this point is equal to this. So we are going to use the concept for distance calculation in order for us to find the value of V. And what do we mean? We understand that under speed time graph, the area represents distance. Okay, so we're going to find area up to this part of the diagram. So the first part, we can see it represents a triangle. Then the other part, which has been, for the sake of demonstration, has been shaded a bit, represents a trapezium. So we are going to find the areas of the two parts, and which when added should equal the distance which has been given in the question, which is 115. So let's do that. Part B. So we are saying, first of all, we calculate distance from 0 to 8 seconds, and then we shall calculate the distance from 8 to 10 seconds. So we are saying from 0 to 8 seconds, distance is represented by this triangle here. Okay, so we are saying area is equal to distance, which is, because it's a triangle, we are going to use this half base times height, which in our case, our base, we have 8, then height is going to be 20. So we have 1 over 2 times 8 times 20. So this is going to give us, you can say 2 there, it's 1, 2 there, we have a 10. So 8 times 10 times 1, we are going to have 8. So the distance for the first part of the diagram that we are considering, which is the triangle, is equal to 80. We move to the other portion where we have time between 8 to 10 seconds. So we are saying between 10 to 8 seconds. 8 to 10 seconds. So, okay. So this, we understand that it is being represented by a shape which is a trapezium. So we are going to use the formula for area of a trapezium. We are saying area, which is representing distance, is equal to, so we get the formula for area of a trapezium, which is 1/2, then the two parallel sides, the shorter one plus the longer one times the height. This is the formula for area of a trapezium. So we can substitute the parts, which is 1/2 times what is our A, what is our B. So let's check the diagram here. The shorter side of the trapezium is this part where we have the V. So we are going to put V for A, then for B, we are going to use 20. For height, it's the difference between 8 and 10. So our A, we are saying, is equal to V because it's not known, plus our B is 20, which is the longer side, times our height is going to be the difference between 8 and 10, which is 2. So this is going to come to, we can say 2 there, it's 1, 2 there, it's 1. So we remain with the V plus 20. This is the distance when time is, between 8 to 10 seconds. Okay, so we are saying now, when we add these two, they should equal the distance which has been given in the question as 115 meters. So let's do that. We're saying now the distance is going to be equal to 80 plus V plus 20. Simplified to 80 plus 20, we are going to have 100 plus V. Now this distance has been given as equal to 115. So we are saying 100 plus V is equal to 115. Okay, so we can simplify to get the value of V. So this 100 plus V, we understand these are unlike terms, so we are going to say V is equal to 115, then minus 100. So our V is equal to 15. Okay. Now, what is this V for? Getting back to the question, this V, it represents the speed in meters per second. So we are going to say V is equal to 15 meters per second. So this is how you get the value of V. Initially, you find the distance from 0 to 8 seconds plus the distance from 8 to 10 seconds. Then when these added together, they should equal the 115 which has been given in the question. That's how we are going to find the value of V, which is 15 meters per second in this case. Okay, we can quickly move our attention to the last part of the question. It says calculate the average speed of the object in the first 14 seconds. So first 14 seconds goes up to this point here. Okay, so for C, average speed is equal to total distance. Okay, total distance over total time. Total distance over total time. Now, when we look at what the question has presented here, average speed of the object in the first 14 seconds, meaning we need to know distance up to this part of the diagram here. But as far as we are concerned, we have just calculated the distance up to the 10th second. So we need to add the distance which is going to be known by finding the area of this part added to what we already know. Okay, so we are going to say distance. Let's find the distance between, or we say 10 to 14 seconds. 10 to 14 seconds. So distance is equal to, because this represents a rectangle, we are going to simply say L times B. So our L is going to be 4, our length is going to be, our breadth is going to be 4, our length is going to be the value of V, which in this case is 15. So we're saying distance is equal to L times B, which is going to be, our length is 15, our breadth is 4. So this is going to give us 60 meters. So this distance plus the one from 0 to 10 seconds, which has been given as 115, is what we are going to have as our total distance. So we are saying average, let me write it in full, average speed is equal to total distance over total time. So this, in our case, our total distance will be 115 plus 60 divided time is 14 as given in the question. So 115 plus 60 will give us 175 over 14. So this, when simplified, is supposed to give us 12.5 meters per second as the average speed up to the 14th second. So this is what we are supposed to do in terms of the calculations. I hope you find this helpful, and I'll see you in the next one.